Well, first of all, let me welcome everyone who's joined us this afternoon here on Eastern Time, or in the morning if you've joined us from some of the other locations. Today we will have guests that will be joining us, and I'll introduce them in a little bit of time. But I'd like to start and ask Aaron Ayton to read our disclaimer, please. Aaron?
Thanks, Doug. The purpose of this call is to provide investors with an update on Medivolve's business developments with a primary focus on its subsidiary collection sites. The views, information, or opinions expressed by our partners are solely those of the individual presenters and do not necessarily represent the views of Medivolve and/or its directors, officers, or employees. Medivolve is not responsible for and has not in all cases verified for accuracy any of the information to be provided by our partners on this call. During this call, Medivolve may make statements that contain forward-looking information within the meaning of applicable Canadian securities legislation. Forward-looking information will include, but is not limited to, statements with respect to the results of collection sites cubes, the proposed rollout of additional testing sites, the pursuit by Medivolve of investment opportunities, and the merits or potential returns of any such investments. Forward-looking information is subject to known and unknown risks, uncertainties, and other factors that may cause actual results to be materially different from the conclusions, forecasts, or projections expressed or implied by such forward-looking information. Certain material factors and assumptions have been applied in drawing the conclusions or making forecasts or projections reflected in the forward-looking information. A description of the factors that could affect and the assumptions underlying forward-looking information can be found in Medivolve's annual information form, financial statements, and accompanying management discussion and analysis, as well as public disclosure documents that are available for your review under Medivolve's profile on SEDAR. Participants should not place undue reliance on forward-looking information. Medivolve does not undertake to update any forward-looking information except in accordance with applicable securities laws. Thanks, Doug.
Thanks a lot, Aaron. Today, we're going to take the time to talk a little bit as an update on our collection sites operation. In a minute, I'll turn things over to Tim Shelburn. Tim is our president of collection sites and COO of Medivolve, and he will give people an update similar to what was released today in our press release. I will talk a little bit later about some of the exciting plans we have for the future. And we'll also introduce everyone to the team at Marvel Diagnostics and the exciting research that they're doing. So to start, I'd like to turn things over to Tim Shelburn. Tim.
Hey, welcome everybody. Thank you for joining us today. Yes, we're very excited to say that we're announcing our January sales of 73,973 test kits sold at an average price of $96 for a total of approximately $7.1 million in January. Currently, we've got through January, we had 62 cubes in operation. By February 15th, we'll have another 20 cubes operational across the nation. You can actually find those locations on our website at testbeforeyougo.com. In addition to that, we'll have an additional 25 cubes by February 25th. So our cube rollout installation has slowed down a little bit due to various issues, mostly related to COVID issues, weather, and then we determined to optimize the current cubes we had out, which reflects the $7.1 million in sales through January. So we're very excited to share that number with you today, and excited to share what's coming up in February.
Tim, a couple of things that I'll address. I know we've had questions on this. One is that we're not reporting averages the way we had in the past. We have a lot of cubes on the ground now. We are getting those up and operating. In January, the 7.1 million was a result of about 32 fully operational cubes. We're very happy with the cubes that are fully operational, but it does take time to get them maximized to the point where they're operating at their full effectiveness. One of the things Tim mentioned, and I think it's very important, is that we're always looking at sites we have and whether or not they're being maximized or whether or not they're efficient and whether they should stay in place. It's no different than product portfolios where you look at your bottom 10%. Even I've been with sales forces where you look at your bottom 10% and you constantly try to improve or you change them. So we will move sites if they're not performing effectively and not just necessarily drop new ones. So it's a matter of maximizing what we have. So Tim, anything else on an update from that? I know the weather has played some factors. I know COVID restrictions.
Weather has, especially on the East Coast, of course, it's played a little bit of factor as far as just cubes maintaining operation, but getting much better. Again, focused on optimizing the cubes on the West Coast, which was again largest part of our revenue. So 32 cubes, mostly in January. As you said, we had a few that came operational by the end of January, but a few factors that are key there. One is, of course, that Google listing to find the cubes if you're looking for a place to test, which is key for us. Marketing wise, we are picking up marketing as far as commercial. I don't know if we've released yet or not to the public, but I know it did run last night on CBS, one of the channels, COVID shows. We are doing some local ads again in local media to enforce testing throughout the locations we've got the sites. So, yeah.
One of the important learnings we had was we were asked to place a site a little quicker than we had first thought in East Hampton, New York, out on Long Island.
Right.
We actually did it, and the local media, the town helped with local media, and the local media created quite a buzz and a sensation. We had immediate results. So the lesson was the importance of local media, and we're using that strategy at a number of our locations to try to get the awareness out much quicker.
Yeah, East Hampton's actually continues to be one of our most successful locations. So even with weather, yeah, for sure.
Great, very good. To say that that we're pleased with our results would be certainly an accurate statement. So thanks, Tim, and to the entire team at Collection Sites for the hard work. I know it's been challenging at times, but it certainly is paying off. And as we continue to grow, you look through our data and you find that prior to events, we really do see increases in testing requirements. We saw that prior to Thanksgiving. We saw that prior to Christmas. I'm betting we'll see it in a couple of days prior to Super Bowl if people are trying to gather for Super Bowl parties, which I hope they don't gather too large a crowd. But the other thing I think is at Easter, I think we'll also see similar to what we saw at some of the holidays when people want to get together with families, that testing requirements go up. So we're seeing a bit of that cycling as well. And I think that's important to note. So with that, I'd like to pass it over to the team at UCLA. I'm going to read this because it's too impressive for me to try to remember. But I would like to introduce you to Professor Pirooz Kavapour. He's currently Professor of Mechanical and Aerospace Engineering and Bioengineering at UCLA. He's the inventor of the BlowFISH technology. He has studied particles, droplet dynamics, and thermal sciences with biological applications since he completed his doctoral work in the fluid mechanics laboratory at MIT 18 years ago. He has extensive expertise in heat and mass transfer and has started at least one company in the energy storage space. There are few individuals so perfectly positioned to accelerate the design of the collection system to maximize the harvesting of virus of exhaled breath condensate in the shortest time possible. Professor Kavapour leads the Marvel Diagnostic technical team. Professor, I'll turn it over to you. Pirooz, you're on mute.
I thought I can break into the mute, but obviously my voice cannot break into the mute. Thank you very much, Doug, everybody, all the audience. It's our pleasure to have a collaboration with Medivolve, and it's been a pleasure. And we are very excited about our technology, Marvel Diagnostic. Before I sort of give you an overview of what we do, I would like to introduce my partners, Professor Jeff Roberti, Professor of Bioengineering at Northeastern University in Boston. He's an expert in many areas, which is interface between engineering and biology, very knowledgeable with the detection and so on. The other partner of us, Professor Jonathan Rothstein at UMass Amherst, also three of us were lab mates at MIT almost 20 years ago. And we not only are a partner on this, we are a collaborator and best friends. Also, the business side of Marvel Diagnostics is run by Dr. Leila Milmoen, who is a PhD in chemical engineering, and our MBA guru, business guru, who's running everything else but the technology, which is very important in these applications. So I'm just going to give you a brief overview of the Marvel Diagnostic technology. So when the whole COVID thing happened, we decided we need to contribute, and putting our mind together, we realized testing is one of the most essential things, fast testing, accessible testing. And through our previous experience, we came up with this technology which can convert exhaled breath with the virus inside of it, if there's any virus, with the particles that come out of lung, to be able to capture them in a very non-invasive and quick way. There are a couple of advantages to this technology. One, unlike saliva, nasal swab, and others, you actually attack directly the infectiousness of the disease, what comes out of breath, which is significant. It's non-invasive. It's easily can be done by any individual because just simply blowing into a device. Just for the clarity, this is different than other so-called breathalyzer type of tests, which mostly focus on what's called a volatile component in the breath, seems like a breathalyzer for alcohol consumption, which look at the gases inside the breath. However, our technology is targeting on capturing viral particles. So we go after the actual virus, not the secondary effects, which would have been the volatile components. Our game plan is to have a collection ready for the clinical trial very soon. After that, we are working on another technology to use antigen type of system to start detecting. And down the line, we're gonna use hopefully a FISH technology, which is a state-of-the-art technology for detection of RNA, which we would like to combine all of these with our collection, which hopefully gonna make a point-of-care system that can detect in a very low cost with a very high efficacy of these systems. So I can tell you more, but because of time and professors used to like to talk a lot, so I'd rather control myself. I'm gonna let Jeff, if he wants to add a brief thing, and if not, if Leila want to add anything, otherwise we're throwing back at you, Doug. Thank you very much, and I would be more than happy to answer any questions if anybody has.
So I would just like to add just a few words here. The collection system is going to be rolled out in multiple phases. The first part is, of course, the collector, which Pruz has described to you, which is a breath harvester. It's a really interesting technology based on Pruz's invention of continuous dropwise condensation, which efficiently converts your breath to a liquid very fast. So just a few puffs does it. And the first phase of this system is going to be you blow into the puck very simply, 30 seconds or so, and then we collect the virus out of the puck with a swab and just run it for RT-PCR. The next phase is actually collecting the liquid directly from the puck, which is much more convenient. And Jonathan Rothstein, he's not here at the moment to explain that, but has worked on a system to direct the fluids into a vial very easily. And then the last part is the FISH detection system, which can be either done, a similar system can be done with an antigen detector, and the other one can be done by directly labeling the RNA with probes. So that one is our ultimate goal, and we think it will eventually replace RT-PCR for diagnostic of respiratory infections when it's coupled with our BlowFISH system. So we think there's a lot of upside potential well past COVID. Great for COVID, but well past it, I think we have a winner of a detection system here. So anyway, I'll let it go back to Doug here or Leila if she wants to say anything about the business side.
I'm good here. I start talking when all of you see one of these devices in your hand. See you, Doug.
Great. Pruz, a little, or Jeff, either of you, if you could tell us a little bit. You mentioned beyond COVID with the device. There was some discussion on the ability to collect particles from air. Pruz or Jeff, could you talk a little bit about the potential there as well? I know all of this is research, and after spending 30 years in medical and pharmaceutical, asking researchers about time and everything else is always an issue. But if you can tell us a little bit about what you're also looking at.
So I sort of tried to set the table for Jeff because he also. Yeah. So one thing about testing, of course, the individual testing, but as the society start opening up and get ready for it, as you can imagine, airport terminals inside of airplanes, schools, and everywhere else require what's called a sentinel systems that monitor, just like we do for a CO2 gases or other gases at different places. You need sentinel places to make sure there is no pathogen in the air. And there is a big need on a fast and accurate testing of that, and frequently during the day. And as the testing goes right now, you cannot swap or take sample from the air because everything is liquid based. Our system seems to be the only one that's focusing on converting from the gas phase, the steam phase, to the sample that can be tested. So I let Jeff sort of put a little bit of his 2 cents on that part.
Right. So the Sentinel system represents a completely different challenge. And that is you have one, you may have one infectious person in a very large airspace. So we've done some preliminary designs showing the feasibility of us basically compressing all the liquid out of the air onto our collector, which is it's built to do. This was originally a fog harvesting system that Peru's was working on. And we think we can take large volumes of air and think of a jet engine just compressing everything down into a liquid condensate that we can then control the volume of to raise the concentration of that one person's antigen in a short period of time. So the system we envision is one that is a continuous flow system, which is unlike some of the filter systems that you've seen out there where we would actually compress the air down into liquid. We're not really compressing the air, we're just harvesting the liquid out of it and then condensing the liquid down to a volume in which we can detect virus from a large space, even if there's 1 or 2 people in there that are emitting a fairly small volume of virus. So we've been working on that. That's a very, very elegant and difficult fluid mechanics problem. But I would say Jonathan and Peru's are probably the 2 best people on the planet to put that together. And we've already got what I think is a viable design. We haven't implemented that design yet, but we're working on that technology at the moment. So I think it could be a game changer if you can basically swab the air in these facilities where a lot of people are and detect early, an early warning system for pathogens.
Cruz, one other question we've had is the rollout schedule. I know we have the 3 phases that you mentioned around the collection system itself, the collection system combined with some sort of an antigen type of read, and then the full ability to go to a collection system basically to do a similar job to what a PCR is doing today. Can you give a little bit of an update on sort of the milestones and the commercialization?
Sure. I would like to add a couple of things that you guys can realize what we're doing as we move forward. The first rollout is we would like to go after what's called EUA, the emergency authorization from FDA for the collection system, which we like to call BlowFISH. And that is essential because that's on its own is not only have a high impact, just the collection, it's a huge business opportunity because it can strongly replace a lot of other tests that's being done now just for the collection of the samples. And we would like to move with that because then if we get an EUA for that, then we can actually have it start selling as we move forward for the other phases. As we are speaking, the manufacturing has been started and the clinical trial will begin. And for EUA, for those of you who are not aware, you're required to have 30 positive and 30 negative with a high accuracy, over 95%, to be able to submit to FDA. We already have communication with FDA about what they require from us to do. And because we are also part of NIH supported grant, we actually, we are having this somehow pass, like they're helping us communicate with FDA with more effective way to expedite the process. So that would be within probably 2 months, I would say. We're going to get to the end of our clinical trial, and right away we prepare for submit for EUA. Hopefully within a month after that, we get the EUA for that, while we are also working in parallel on antibody testing. And hopefully that comes out, I would say between 3 to 4 months from now. And then after that, I would say within the 6 months, we get to the last phases. And of course, some of these depends on each other. Some of them depends on the manufacturing and all the things that we're going through. But the earlier timeline that I would say we are much more confident about is a rollout of the clinical trial within 2 months and the EUA probably a month after that, and so on.
Okay, and your clinical trial plans, do you have any plans for where you'll be conducting the trials, et cetera?
Yes, so the clinical trial will be performed at UCLA Medical School. We have a partnership with actually infectious disease program that they would like to run it side by side by what we do. Unfortunately, Southern California get hit really hard with COVID, which means more samples for us to taste. So it's unfortunate, but we take advantage of having a lot more samples for our testing. There's also potential to send some of our samples to be run out of the state. We are in conversation with state of Louisiana for some tests to be done there as well. So not only we only do it at UCLA, we're going to do it also in other states at the same time.
Great. So what I'll do is sorry, Peruzzi, one other question I had, there was some mention of certainly this is a product that goes on well beyond COVID. I mean, some of the other respiratory type diseases that that you envision you'd be able to utilize this for.
I quickly say something, and maybe Jeff want to jump in on that one, because the sign between our team is when I unmute, that means I want to talk. So Jeff is unmuting. So I'm gonna again set the table for the real bioengineer to talk about it. But think about tuberculosis. Test of tuberculosis is a very complex thing, and it's really hard to do. And actually, it kills 1 million people a year worldwide. According to people in infectious disease, this can be actually an even bigger game changer for tuberculosis. Also for cystic fibrosis, it's really hard to pick up sample from lung. So they really don't know what kind of infection exists in the lung. So they usually end up giving a wide variety, a large spectrum of antibiotics to try to cure the infection. However, this might potentially pick up the exact infection type of a bacteria or whatever caused the infection, so they can focus on that. And they believe this is a huge game changer in a cystic fibrosis. Future is very bright for the detection for our system. Jeff, go ahead.
Yeah, I was just going to say it's very hard to take samples from lungs, and if we can condense the air out of the lungs and capture infectious elements, there's a large market, as Peru said, for tuberculosis. Also for what kind of co-infections are happening with the flu or with other diseases. And the cystic fibrosis field is really they're really frustrated about how to detect infections that are concurrent with the disease, because those are the ones that take you down. So we've got a lot of interest from cystic fibrosis people. And then the last thing I will talk about is something called exosomes. And your lungs actually generate exosomes, which are exhaled in the breath, and those can be indicators for diseases elsewhere. And we had interest from a friend of ours at Pfizer, who was very interested in detecting liver issues through exhaled exosomes. And they consider, not taking urine, not taking blood, the holy grail of diagnostics, right? And if we can use our system to pull indicators out of breath, that could be, a really nice application later on as well. So, and the exosome field is something that's just starting to really take off. And these little vesicles are carrying information all over the place. So, and there's a lot of them coming out of the lungs that we know of already.
Great. Well, I will thank Peruz, Jeff, and Leila for joining us today. If we have any follow-up questions that anyone has specific to the technology or to Marvel, we'll certainly, talk to you and get those answered. One of the questions I get a lot is post-COVID. What are we going to do post-COVID? I think we've talked a little bit about the Marvel plans post-COVID, but I do want to address one of the exciting opportunities, I think, and probably the most exciting opportunity we have, which is we have a model for customer acquisition that I think is as effective as any I've seen. We literally have our customers seeking us out either through Google searches. They approach and they come to our collection sites. We have assembled literally hundreds of thousands of customers. We have their information. We're certainly going to do everything we can to make sure that we utilize this low cost of customer acquisition to monetize, to offer some medical service providing that can get the same access and convenience that they get from collection sites at a very cost-effective basis. And at the end of the day, this is probably one of our most valuable assets that we've gathered through collection sites, is a database of a very large number of customers. You're going to start to hear some exciting plans in the future on things like telehealth, remote patient monitoring, some of the things we are looking at how we can begin to drive services to our patient database. and really make it an easy access and a disruptive model that takes away from some of the traditional medical service provisions that people have had. So with that, I'm also going to address a couple of questions that have come in. One question is regarding the financials. Our year-end financials will be released in April. There will be our audited 2020 financials. So we will have those out at that time. We've asked, I had a question that was addressed, how many collection sites do you have up and running currently? Tim, if you want to go ahead and just give it a quick update again, repeat on your number of sites you have up and running.
Yeah, sure. As of today, Doug, we've got 62 in operation. As of February the 15th, we'll have an additional 20. And by February 25th, there'll be an additional 25 there. And then we're just working on schedule for March and beyond, which again, all those sites can be viewed and on our website at testbeforeyougo.com.
Great. I've also had questions around things like what will the vaccination programs do to, to testing? First of all, and I guess I'd say, unfortunately, testing isn't going away anytime soon. The numbers of individuals that are still being impacted on a daily basis with COVID are still very, very large. So we do not anticipate seeing huge falls off in the need for testing. We also believe that as vaccination programs roll out, there may be the need to begin to understand antibodies and whether or not antibodies have formed from people that have been vaccinated. So at the end of the day, we see that testing isn't going away anytime soon. We're also looking at how we can put this database of customers to use post-COVID, but we're not going to be out of the COVID space for, unfortunately, through 2021, we expect to be operating very aggressively in the COVID space. Good.
Doug,
so,
if I could, oh, sorry.
Sure, go ahead.
Yeah, so just one thing that I think would be worth talking about that I don't believe Tim has touched on yet is just the recent announcement with COVID Shield and the Nutrell deal.
Oh, yes, absolutely. Tim, if you could give an update on the opportunities around the Nutrell.
Sure. So Nutrell is a product that is a spray that leaves very no film. It's an eight-minute dry time that's actually protectant from 9 different viruses, including COVID. It lasts up to 90 days. I believe the testing stopped at 90 days, Doug. They tested it to the 90-day range, and if I recall, it's a 99.9% kill rate at the 90th day. So we're very excited about that product. That's a product that we're going to be offering through all of our folks who purchase test online, and it is offered for home and business. So we're very excited to be rolling that out. We're going to actually roll that out initially in Las Vegas, and then continue to roll out across the nation quickly.
Thanks, Tim. The other thing I've had questions on is what are our plans in Canada? We're certainly looking at Canada as a market. Unfortunately, and I say this being a Canadian, also somebody who's dealt within the Canadian medical space for about 30 years, that I'm a little disappointed where Canada is on some of its testing technologies and approval on testing technologies, but that is changing. So we are looking at ways that we can begin to do more within the Canadian marketplace. Right now, our biggest focus is in the US. That's still where we have access to a number of different technologies. As most people know, we do PCR, we do antigen, and we do antibodies in the US. And we're able to do that very successfully. So right now, our biggest focus is where we have the most flexibility to be able to offer testing services, and that is south of the border. But things do change, and we're certainly monitoring and seeing how we can expand beyond what we're doing today.
Yeah, Doug, if I could touch again on sure. the Nutrell product. The product is actually called COVID Shield, and you can actually get more information at covicshield.com. And again, that product is an instant kill on a surface for 90 days. So no virus can live on that surface for 90 days. So that could be grocery store counters, elevator buttons, door handles, desks, chairs, restaurant. It is biodegradable. It's a green product, so it's not harmful. And again, you can see more information on that at covicshield.com.
Great. And with that, I just want to thank all of our participants. I want to thank all of the individuals who joined and listened into the webinar. The webinar was recorded. It will be available for people to view at a later date. So I just want to thank everyone, and we'll continue to keep you updated with webinars and with announcements as we get information that we believe is relevant for us to disclose. Thanks, everyone. Have a wonderful day, and we appreciate your participation, and thanks to the team.